Chapter 14, Logical Reasoning. I encourage you to open up your Exploring Public Speaking online textbook. We are on page 298. It's at the top of the page, but if you have the PDF downloaded, it's actually page 313. So, in this chapter, we're going to look at developing logical support for your speeches. In chapter 13, we reviewed ancient and modern research on how to create a persuasive presentation. We talked about persuasion, and it doesn't just depend on one mode, but the speaker has to have their personal credibility. They have to understand what the values and beliefs are of the audience. They have to really connect the audience with their personal persuasive purpose. We talked about ethos, pathos, and logos, that Aristotle felt like in order to persuade an audience, you had to have logical proof, pathetic proof, emotional proof, and credibility for your audience. So those are some of the things that we talked about. So this is really looking at logos. This is looking at logical proof and our reasoning that we use to support our statements in our presentations, and how easy it is to have fallacies with our reasoning. Although it's not a perfect or literal analogy, your book says we can think of a correct reasoning like building a house. To build a house, a person needs materials, so premises and facts, a blueprint, logical method, and knowledge of building trades, so critical thinking ability. If you put them out in a field with drywall, nails, wiring, fixtures, pipes, wood, and other materials, and handed them a blueprint, they would need knowledge of construction principles, plumbing, and reading plans, and some helpers. Or no building is going up. Logic could also be considered like cooking. A cook needs ingredients, a recipe, and knowledge about cooking. In both cases, the ingredients or materials must be good quality. Your information and your facts must be true. The recipe or directions must be right. The process that you go through in your logic must be correct. And the cook must know what you're doing. So, as we continue, we're going to look at developing logical arguments. We're going to define critical thinking, deductive reasoning, and inductive reasoning, distinguish between inductive and deductive, know the four types of inductive reasoning, and know the common logical fallacies, become a more critical listener to public speeches and more critical reader of source material. So, what is correct reasoning? Again, it's thinking like building a house or cooking. There are specific steps that must be followed to get to the right place. It's an integral part of critical thinking, recognizing standards, forms of logic, and avoiding fallacies. So, what is inductive reasoning? Examples or specific instances are used to supply strong evidence for, though not absolute proof of, the truth of the conclusion. So, inductive reasoning. Inductive reasoning happens when we look around at various happenings, objects, or behavior, and we see patterns. From those patterns, we develop conclusions. There are four types of inductive reasoning based on different kinds of evidence and logical moves or jumps. So, inductive reasoning is associated with scientific method. Conclusions are tentative. So, by that meaning, as advancements happen, as more information is gathered, sometimes our conclusions are no longer accurate. But our conclusions are tentative. At this point in time, based on all the information we have, this is the conclusion that can be drawn. Bottom up thinking or reasoning from specific instances, and this is something we commonly use. It can be disproven with more evidence. So there's four types of induction. Generalization is a form of inductive reasoning that draws conclusions based on recurring patterns or repeated observations. So, vocabulary.com, your book says, goes one step further to state the process of forming general concepts by abstracting common properties of instances. To generalize, one must observe multiple instances and find common qualities or behaviors, and then make a broad or universal statement about them. For example, if every dog I see chases squirrels, then I would probably generalize that all dogs chase squirrels. If you go to a certain business and you get bad service once, you may not like it. If you go back and get bad treatment again, you probably won't go back again because you have concluded this business always treats its customers badly. However, according to the law of logic, you cannot really say that. You can only say, in my experience, this business treats customers badly or has treated me badly. Causal seeks to make cause and effect connections in your reasoning. So, causal reasoning is a form of inductive reasoning we all use from time to time without even thinking about it. If the street is wet in the morning, you know that it is rain based on past experience. Of course, there could be another cause. The city decided to wash the streets early that morning. But your first conclusion would be rain. Because causes and effects can be so multiple and complicated, two tests are used to judge whether the causal reasoning is valid. Good inductive causal reasoning meets the test of directness and strength. The alleged cause must have a direct relationship on the effect, and the cause must be strong enough to make the effect. If a student fails a test in class that he studied for, he would need to examine the causes of the failure. He could look back over the experience and suggest the following reasons. Number one, he waited too long to study. He had incomplete notes. He didn't read the textbook. He wore a red hoodie when he took the test. He ate pizza from Pizza Heaven the night before. He only slept 4 hours the night before. The instructor did not do a good job of teaching the material. He sat in a different seat to take the test. His favorite football team lost its game on the weekend before. So think about these. Which of these causes are direct enough and strong enough to affect his performance on the test? All of them might have a slight effect on his ability, on his emotional, physical, or mental state, but not all of these are strong enough to affect his knowledge of the material if he had studied sufficiently and had good notes to work from. So, not having enough sleep could also affect his attention and processes more directly than maybe the pizza or the football game. His hoodie being red is superstitious, so that wouldn't have a direct cause. Taking the test while sitting at a different seat may have made him uncomfortable, but is that going to make him not know the material? So, causal seeks to make cause and effect connections. Causal reasoning is susceptible to four fallacies: historical fallacy, slippery slope, false cause, and confusing correlation and causation. The first three we'll discuss later, but the last is very common. And if you take a psychology or sociology course, you will study correlation and causation. Well, there's a link in your book to a TED Talk that talks about it a little bit more. Sign reasoning is a form of inductive reasoning in which the conclusions are drawn about phenomena based on events that precede or coexist with, but not cause, a subsequent event. Signs are like the correlation mentioned above. Under certain causal reasoning, if someone argues in the summer more people eat ice cream and in the summer there is statistically more crime, therefore eating ice cream causes more crime, that wouldn't be an accurate, that's not reading the science accurately. There are two things that happen at the same time, but that doesn't necessarily mean that there's a relationship between one another. Analogical reasoning. As mentioned above, analogical reasoning involves comparison. For it may be valid, the two things, schools, states, countries, businesses, must be truly alike in many important ways, essentially alike. Although Harvard and your college are both institutions of higher education, they are probably not essentially alike in very many ways. They may have different missions, histories, governance, surrounding locations, sizes, clientele, stakeholders, funding sources, funding amounts. So it'd be foolish to argue Harvard has a law school, therefore our college also must have a law school. On the other hand, there are colleges that are very similar to our college in all those ways, and so the comparison we would make between them would be valid. You've probably heard the phrase, this is like comparing apples and oranges. When you think about it, though, apples and oranges are more alike than they are different. They are both fruit after all. This observation points out the difficulty in illogical reasoning. However similar do the two things have to be for there to be a valid analogy? Second, what is the purpose of the analogy? Is it to prove that State College A has specific programs, therefore College B would have the same programs too? Are there other factors to consider? Analogical reasoning is one of the less reliable forms of logic. Sign, two or more things happen at the same time. We've already talked about that. That signal each other, but neither are necessarily causes. Generalizations. The more examples or instances, the stronger the argument. The conclusion must be stated to reflect the evidence and avoid big inductive jumps. Causal reasoning: causes must be direct enough, strong enough, and have past examples to support it. Sign reasoning: distinguish between a correlation and a causation. Correlation is common in social science research. Causation is very difficult to prove in social sciences. And in a logical, the more the two things compared are alike, points of similarity, the better. An analogy is not necessarily the strongest form of reasoning, but it is common. So, deductive reasoning is what we'll talk about next. Deductive reasoning is a top down reasoning. It deducts conclusions from already accepted premises and uses syllogism format. Major premise, all X or Y. Minor premise, Z is a member of X group. Conclusion, therefore, Z is Y. So, syllogism example. Major premise: college students must complete Communications 1110 to graduate. Minor premise: Caroline is a college student. Therefore, Caroline must complete Com 1110 to graduate. Deductive reasoning: enthymeme: major or minor premise missing or assumed. Since Caroline is a state college student, she has to complete Com 1110 to graduate. Possibly a place for misinformation or fallacy. Problems in deductive reasoning: faulty major premise: if the premise is not true, the conclusion cannot be true. It's the wrong formula. Minor premise is misstated. Enthymeme is unethical because of omitted wrong information in the premises. So if you looked at deductive reasoning, you'll see in your book on the most common deductive reasoning that we see. All men are mortal, the major premise, something everyone already agrees upon. Socrates is a man, minor premise, an example taken from the major premise. Socrates is mortal. Conclusion, the only conclusion that can be drawn from the first two sentences. The other is major premise: all dogs have fur. Minor premise: Fifi is a dog. Conclusion: Fifi has fur. So consequently, there are other premises. All dogs bark. Fifi barks. Fifi is a dog. The minor premise is stated incorrectly. We know other animals bark, notably seals. Although it's hard to think of a seal named Fifi, the minor premise would have to read Fifi is a dog to arrive at the logical conclusion. Fifi barks. However, by restating the major premise, you have a different argument. Major premise: dogs are the only animals that wag their tails when happy. Minor premise: Fifi wags her tail when she's happy. Conclusion: Fifi is a dog. Another term in deductive reasoning is enthymeme. This odd word refers to syllogism with one of the premises missing. So if the major premise is missing, the minor premise: Daniel Becker is a chemistry major. Conclusion: Daniel Becker will make a good SGA president. So there's no major premise there to lead you to believe that Daniel Becker would make a great SGA president. So logical fallacies are errors in using deduction and induction. There are many of them. They commonly use Latin terminology. So generalization fallacies: hasty generalization. Hasty generalization means making a generalization with too few examples. It's so common that we might wonder if there are any legitimate generalizations. So, a premise: Albert Einstein did poorly in math in school. Conclusion: all world renowned scientists do poorly in math in school. And secondary conclusion: I did poorly in math, so I will become a world renowned scientist. I can tell you I do fit in that first conclusion. I did poorly in math, and I will assure you I have no business being a world renowned scientist. So that's a hasty generalization. Statistical fallacies is when you take a small sample that's not well representative of the full sample and you make a poll to make that sound like it's truth. Causal fallacies. Historical fallacy: post hoc ergo propter hoc. Just because A happens doesn't mean it causes B. Slippery slope. I think this is one we've heard a lot. I find that sometimes I say that a lot. that this is a slippery slope. A false accusation of slippery slope can be a fallacy, a law of unintended consequences that we can't foresee all its effects. Think about, if you remember when you were a kid, the children's book, If You Give a Mouse a Cookie, or If You Give a Moose a Muffin. It's a good example of a slippery slope. It tells that if you give one thing, if you give a mouse a cookie, then it wants some milk. And there's a series of things that has to happen. If you do this one thing, then they're going to want this next thing. Anytime my niece wants new bedding, my brother-in-law starts quoting, if you give a mouse a cookie. If you give Ella new bedding, she's going to want to paint her room, and then she's going to want new curtains, and then she's going to want a new rug. So it's a slippery slope where you might do one thing, but then all of these consequences that you can't foresee necessarily come. And then there's false cause. That's when you have a lack of strength or a lack of directness in your causal fallacy. Other fallacies: guilty by association. You're at the wrong place at the wrong time. Appeal to pity. Inappropriate appeal to pity or emotions to hide the lack of facts or arguments. So I don't have a lot of good information, but I'm going to appeal to your sense of empathy. I will tell you, I served on a jury last week, actually. I served on a jury last week, and I would venture to say that the state did not have a lot of evidence in the case. And so they tried to compensate for that. They tried to make things look too simple and say, this is a really simple case. A plus B equals C. But in reality, as the jury were going over the evidence, you had to kind of do a lot of connection in your mind to make A plus B equals C. They did not connect things with evidence, but they tried to oversimplify that information. Other fallacies: ad hominem, a fallacy that attacks the person rather than dealing with the real issue or dispute. I would say, think about maybe when we're kids and we're fighting with someone, and because we don't agree, and then our comeback is, well, you're ugly or you're stupid, and because we don't really know what to say. I would say that happens a lot of times in sometimes debates, political debates, where they begin to attack character instead of the issue. Straw man is a fallacy that shows the weaker side of an opponent's argument in order to more easily tear it down, often misinterprets or overemphasizes a position. And non sequitur, a fallacy where the conclusion doesn't follow from its premise. So you made a statement, but the conclusion you've drawn from that is not valid. It doesn't connect. Appeal to tradition, arguing that traditional practice and long-term history is the only reason for continuing a policy. Inappropriate appeal to authority. In contrast to appropriate appeal, sources should be expert on that subject. An argument from silence, making a converse argument from a lack of evidence or information about a conclusion. False analogy, a fallacy where two things are compared that don't share enough similarities. False dilemma, a fallacy that forces listeners to choose between two alternatives. More than two alternatives exist. And red herring, creating a diversion or introducing irrelevant, kind of off-the-wall information to kind of get off the subject of the argument. You'll see that in presidential or political debates also. Plain folks, making someone appear like they're just like you when they're not. Again, this happens a lot when you're watching presidential debates. Bandwagon appeal to the majority, a fallacy that assumes that because something is popular, it's good and correct and desirable when it may not necessarily be. So I know that this chapter is really, it's a little complicated. In your book, they have a lot of great examples for each one of these that can help break this down. The important thing to remember as you're developing your persuasive speeches is that you let your research guide your conclusions. Don't try to stretch the information that you have to make it say what you need it or want it to say. Your research should tell you what it's saying. Your research should explain for you. You don't need and you should not have to force it to draw the conclusions that you need in your speech. So make sure that you study your research, you read your research thoroughly to make sure that you're interpreting correctly, and that way you're providing the best information for your audience.